The graph of the polynomial y equals f of x of degree 5 is shown below. So here's our x-axis, here's our y-axis, and this is our polynomial. Part 1, find an expression for the polynomial f of x. Okay, so if we have a look at the points at which our graph crosses or touches the x-axis, we can then construct our polynomial. Okay, so we were told in the question that our polynomial is of degree 5, and this is an odd degree, which means the arms are going in different directions, and we can clearly see that. We have the left arm up and the right arm down of our polynomial. Now, if the left arm is up and the right arm is down, the leading coefficient must be negative. So we know that we're going to have a minus in front of our polynomial, no matter what it is. Okay, so now we're going to start to look at the points at which our graph either crosses or touches the x-axis. So we've got minus 3, 1, 2, and 3. So at minus 3, at x is equal to minus 3, we can see that we actually have a turning point. Our graph just touches the x-axis. So minus 3, therefore, is a double root. So our factor of x plus 3 is going to be squared. It's going to be a double root. So if our x value is minus 3, then our factor is x plus 3, and this is going to be squared because it's a double root, because we have a turning point. While 1, 2, and 3 are each single roots. So at 1, 2, and 3, we can see that our graph just crosses at those points. So there's not a turning point, and there is not a leveling off or a kink in our graph. So we can see our graph directly cuts the x-axis at 1, it directly cuts the x-axis at 2, and it directly cuts the x-axis at 3. So if x is equal to 1, 2, and 3, then the factors are going to be x minus 1, x minus 2, and x minus 3, and each of these will be to the power of 1 because they are single roots, so to the power of 1. We know that the leading coefficient is negative, thus one expression for f is going to be f of x equals minus x plus 3 squared times x minus 1 to the power 1 times x minus 2 to the power 1 times x minus 3 to the power 1. Part 2. If the curve contains the point minus 1, 192, find the equation of the curve y equals f of x. So what we're going to do is we're going to let k be in front of our polynomial. So we're going to let the equation of the curve be y equals k times x plus 3 squared times x minus 1 times x minus 2 times x minus 3. You don't have to let it be k, you can choose any letter just once it's not x or y. We're then going to take our point minus 1, 192 and label it as x and y. And then we're going to substitute into our equation of the curve, swapping the x values for minus 1 and the y value for 192. So we end up with minus 1 plus 3, which is going to be 2. So we're going to have k times 2 squared. And then we're going to have minus 1 minus 1, which is minus 2. So we'll have minus 1 in brackets. Then we'll have minus 1 minus 2, which is minus 3. So minus 3 in brackets. And then minus 1 minus 3, which is minus 4. So minus 4 in brackets. And this will all be equal to 192. And then k times 2 squared times minus 2 times minus 3 times minus 4 will give us minus 96k. This is still equal to 192. And then dividing by minus 96 on both sides, we get 192 divided by minus 96, which gives us minus 2. So k is equal to minus 2. So the equation of the curve is y equals minus 2 times x plus 3 squared times x minus 1 times x minus 2 times x minus 3.